Another feature of the 3500 is the central door locking system. It comprises 3 control switches. 1, an integral lock and unlock solenoid in the tailgate and each side door. 2, and the control unit. 3. The circuit is powered through an inline fuse located in the right-hand footwell. All 5 locks can be operated simultaneously by turning the key in either front door. From inside the car, the switch mounted on the driver's armrest will operate the locks. The tailgate can also be opened by key in the conventional way. The lock can be isolated from the central system by turning the key fully clockwise before removal. In the event of an electrical failure, the front doors and tailgate can be locked or unlocked by key, and from inside the car by using the door-mounted rocker switches. This is the electrical circuit. You will find it easier to understand as 2 identical relay controlled circuits, one to lock the doors, the other to unlock them. The circuit is protected by an inline fuse. From the fuse on the right, current, red, flows through the 2 resistors and charges the capacitors. A selection made at any control switch will cause both capacitors to discharge through the appropriate relay coil. This momentarily closes the relay contacts and battery voltage is supplied to the appropriate windings of the 5 solenoids, thereby locking or unlocking the doors as selected. Approximately 5 seconds after the control switch has been released, the capacitors, blue, are recharged. Another selection can then be made. Again, by adopting a methodical approach to troubleshooting, time and effort will be saved. First, establish which parts of the system are inoperative. If the failure is total, check the state of the battery, the line fuse, all leads and connections, and finally the capacitors. If all doors fail to lock or fail to unlock, suspect the appropriate relay and its control circuit. It is unlikely that all 5 solenoids would fail simultaneously. If one control switch fails to operate, the fault is in the switch or its connecting leads. If one solenoid fails to operate, check its supply leads and earth connection. Then look for a mechanical failure before replacing it. That completes the section on the electric door locking system. Additional information will be found in the Starvey program Vehicle Electrics 2. Now heating and ventilation. Most modern vehicles are fitted with a heater to raise the interior temperature. The ROVER system comprises a central unit 1 containing the heater matrix and control panel, and a control relay 2. Airflow is provided by a separate blower box attached to the side of the central unit. 3 fan speeds are available. These are achieved by switching resistances into the fan motor supply line. Current flow for the 3 speeds is shown here in yellow. As a further refinement, air conditioning is available on the 3500. This enables a selected in-car temperature to be maintained. In addition to the heater unit, the car is fitted with a refrigeration system. The temperature and ventilation selection panel controls the system electrically by means of vacuum-operated flaps and a mechanical air blend system. 4 relays are used. 3 of these, the air conditioning relay, the magnetic clutch relay, and the heater resistance bypass relay, are located behind the passenger's glove box. The condenser cooling fan relay is fitted at the right-hand side of the engine compartment. The system has 5 fuses, 2 in the fuse box already mentioned in Part 1, and 3 in line. These are the blower motor fuse located inside the instrument binnacle, the condenser cooling fan fuse located near the cooling fan relay, and the special compressor mounted fuse, the thermal limiter. Now we'll have a look at the electrical control circuit and see how it works. When the ignition is switched on, current, shown in red, energizes the air conditioning relay and the driver's control panel. The mode selector on the left and the fan speed selector in the center are both connected to microswitches. They are the only electrically operating controls on the panel. With the mode selector in the max, normal, bi-level or defrost positions, current flows from the mode microswitch to the on-off microswitch on the right beneath the panel. Providing the fan speed selector is not in the off position, current from the on-off microswitch flows through the ambient temperature switch and energizes the clutch relay. Current then flows through the coil of the electromagnetic clutch at the top right of the diagram, and the compressor operates. At the same time, the fan speed selector completes the blower motor circuit shown in red. Speed variation is achieved by completing the earth path through different value resistors. This is similar to the conventional heater control just described. Several safety features are built into the clutch circuit. First, the ambient temperature switch, blue. It de-energizes the clutch relay, green, if the outside temperature drops below freezing point. The other devices are the superheat switch, red, and the thermal limiter, yellow. Let us see how they work. If the pressure or temperature inside the compressor rise above a critical level for a prolonged period, the superheat switch will disengage the compressor clutch by shorting its power supply to earth, causing this thermal limiter to blow. Although the same temperature and pressure levels may occur during normal operation, their duration is not sufficient to cause the unit to blow. The high pressure or Ranco switch, arrowed, senses the pressure at the valves in receiver unit. Incidentally, the operation of this unit is described in the product training workbook on the ROVER air conditioning system. If the pressure reaches a critical level, the switch closes, energizing the cooling fan relay. The cooling fans operate, increasing the airflow through the condenser. On air-conditioned vehicles, the heated backlight can only operate when the mode selector on the left is in the vent, heater, or defrost positions. When the heated backlight control switch, arrowed, is depressed, the mode selector energizes the backlight relay, blue, via the defrost microswitch or via the mode microswitch, yellow. The relay contacts close and complete the circuit through the heater element. The color code used here relates to the selector position. Whenever the backlight relay is energized, so is the heater resistance bypass relay, also shown in blue. In this situation, if the highest fan speed is selected, it will automatically be reduced to speed 3 through the relay contacts. The earth path is shown in yellow. Now let's have a look at troubleshooting the circuit. It will be easier if you consider it in these separate sections. 1. The air conditioning relay. 2. The driver's control panel. 3. The electromagnetic clutch circuit. 4. The condenser cooling fan circuit. And 5. The heated backlight and heater resistance bypass relays. Although the vacuum circuits are important, they are outside the scope of this program. You will find further information in the product training workbook. It also contains a comprehensive troubleshooting guide and checklist. When you are familiar with the circuit, switch on the ignition. Then examine the operation of each of these areas in turn, making a note of any items that do not operate correctly. The various relays can be checked by substitution. The blower motor and control panel can be isolated from the rest of the circuit by disconnecting this 7-pin connector located under the driver's glove box. The micro switches can be tested using an ohmmeter or continuity tester. Connect the test equipment between the appropriate pins of the 7-way socket and check the switch operation as each selection is made. For example, when defrost and low fan speed are selected, continuity should exist between pins 1, 2 and 3. This is shown here in yellow. The microswitch condition for each panel selection is given on your circuit diagram. The blower motor and speed control can each be tested using a 12-volt supply. Connect it to pin 5 of the 7-way socket. The motor speed should increase as successive selections are made. The highest fan speed can only be obtained by earthing terminal 4. If the compressor-mounted fuse has blown, showing that the superheat switch at the compressor has been closed, then thoroughly examine the refrigeration system before continuing with the electrical tests. The gas system should only be checked by a competent member of the staff. Now to test the clutch circuit. Start with the ambient temperature switch located beneath the right-hand bonnet grille. If its contacts are closed and the clutch fails to operate when the correct control selection is made, then check the operation of the clutch relay. If the relay is working, the clutch is faulty and must be replaced. Next, the cooling fan circuit. Disconnect the high-pressure switch and bridge the female connector. This will energize the cooling fan relay and the fans should operate. If the fans do not operate, suspect the relay and check it by substitution. It is unlikely that both fan motors would fail simultaneously. Always take great care when troubleshooting the air conditioning circuit, and for your own safety, before starting work, make sure that you are familiar with the principles of refrigeration, good workshop practice, and the operation of the electrical circuit. That completes this section on air conditioning. Because of the complexity of the system, you may need to rerun the section before continuing. If you want to know more about air conditioning systems, watch the Starvey program Air Conditioning and read the product training workbook on the ROVER air conditioning system.